Okay, welcome to Chapter 4. Starting out with 4.1 is a lot of linear function review. So our first example here, it says given f of x is equal to 5x minus 4. Remember, f of x is the same thing as saying y. So this is in our traditional y equals mx plus b format, or we could say plus a negative 4. So if we had to determine the slope, m is our slope, so our slope would be 5. And if we had to find the y-intercept, that's the b version here. So 0, comma, negative 4. Remember, intercepts are a point. Okay, now again, if you type in a point into my math lab and they wanted it just the negative 4 and they count it wrong, click Ask My Instructor and ask for an override. I will fix it and override that and get your points back for you when you're done with that assignment. All right, if we wanted to graph the line, we would go over to our y-axis, go down to negative 4, plot that point, use our slope of 5, which is technically as a slope 5 over 1. We would go up 5 squares and to the right 1, plot a point. And then connect those with a straight edge, or if you want to do up 5 again to the right 1, plot one more point. I prefer, when I'm doing things by hand, is to use 3 points. Your lines are much more accurate when you have 3 points that you're lining up. Sometimes when you line up just 2 points, your straight edge might be off just a little bit. All right, remember we discussed the average rate of change. That's the same thing as the slope. So that's going to be the same answer there. And the other thing we're going to use the slope for is determine whether the linear graph, if it's linear, your slope is going to determine how you increase, decreasing, or constant. So this is an increasing function the whole entire time because it has a positive slope. If I'm going to have a decreasing linear function, then I have to have a negative slope. And if I'm going to have a constant function, then my slope is 0. There would be 0 times x here, which would cancel out. There would be no x term. So we call that a 0 slope. Next, we're going to look at data. Here's a couple tables and determine if it represents a linear function. And again, we can use our average rate of change. Whoops. Come on, mouse. Go the right direction. There we go. Looking at your x column, notice that from negative 2 to negative 1, I increased by a 1. Negative 1 to 0, I increased by 1. 0 to 1, I increased by 1. And the same is true with 1 to 2. You do that with your y column. 4 down to a 1, I decreased by 3. 1 down to negative 2, I decreased by 3. So it appears that I'm constantly subtracting by 3 over here. So negative 2 minus 3, negative 5. Negative 5 minus 3, negative 8. Since these changes, the change in your y, your change in your x, that is technically your slope, your average rate of change. We also call this your first level difference test. And that's all about your y. So if your x's are counting by a consistent value, ones, go to your y's. If they are counting by a consistent value, this is what we call a first level test. This will always be a linear function when that change in your y's are the same value the first time you check. And there's also something called a second level difference test and a third level difference test, and we'll talk about that later in this chapter. So this is definitely a linear function when these changes are consistent. Now, every once in a while, the author will try to fool you. All right, so instead of counting by ones, what the author might do here at the bottom, so you might want to add this into your list. He'll jump up 2, so he'll go 2 to 4. You'll say, well, that's an increase of 2. But then he'll go from negative 8 to negative 14, which is a change of negative 6. But negative 6 over a positive 2 is still reducing to a negative 3. He just skipped a number in between. So be on the lookout for that. That's still an average rate of change that's the same. So we can take this table, we can say we can create a linear function in the form of y equals mx plus b, and we can put f of x instead of y. Put in your slope, -3/1, which simplifies to -3. And because your data set had the point 0, -2, anytime your x is 0, that's your y-intercept, -2. So we'll put in the -2. All right, so take a look at the second table, and we'll do your first level difference test and determine if this is a linear function. Well, I'll help you out here a little bit. The x's are the same x's as we had in the first table, but now check your y's. And everything looked like it was +4 until you got between 4 and 9, where it was a +5. So here, the average rate of change, or your slope, was 4/1, 4/1, and then it went to 5/1. So because we had this one rate of change that was different, this is not considered a linear function. All right, other graphing techniques that we can use with our functions is some inequalities between the two, and sometimes making a graph can quickly assist what you want to do with these problems. All right, so here, if you had to solve for f of x equals to 0, this we're going to do algebraically, and then we're going to go over to the graph and do everything on the graph, and we can basically answer the same questions from the graph. Very similar to that we talked about when we talked about that piecewise function. So here, f of x equals 0. You take 3x plus 5, put it in for f of x, set it equal to 0, solve it for x. Subtract over the 5, divide by 3, x equals -5/3. This is your x-intercept. Now, if they change the equal sign to a greater than symbol, you really don't have to do the work over again. You just replace the equal sign with the greater than symbol, and then you can write it in interval notation. Now, this is only true if your x term is positive. All right, it's only true if it's positive. If you had a negative x term like this g for x, that would be a different story, because when you divide by a -2 with inequalities, you need to flip your inequality symbol. So if I had g of x here greater than 0, I would take the -2x and add it over first so it's positive, and then divide by 2 so I don't have to worry about flipping my inequality symbol. To solve for f of x equals g of x, this is where we set the two expressions equal to each other and solve for x. So -2x is the smallest of the two x terms. I'm going to add that over to the left. Now that my x terms are camped out over on the left side, it's time to get rid of that constant of +5. So I subtract that over at the same time. 5x equals 10, x is equal to 2. Again, if they put an inequality symbol here, so they replace the equal sign with the greater than or equals to, you can just substitute out the equal sign for that symbol. But you have to make sure that f of x is still on the left side when you did the equation, and it's still on the left side when you do the inequality. That's a key. It has to look exactly the same as when it started. If they've switched the g of x over to the other side, all right, what I would do is say, well, when is g of x greater than or equal to f of x? I can't just say, oh, when x is greater than or equal to 2. That's not true, because I set my g of x function up on the right first, my f of x on the left first. So what we really did, again, we said this is finding the x-intercept. This is finding positive y coordinates. This was finding the two functions where they intersect. They intersect at x equals 2. And this is finding the y coordinates of the f function are going to be bigger than the y coordinates of the g function. So one thing I like to do, especially when we start messing with inequalities and they start moving, like I said, the g of x and the f of x around, sometimes it's better to make a graph. So we're going to look at the graph to the right of your notes. And what we're going to do is we're going to graph these two functions. So I'm going to let the f function be in red. And the g function is going to be in blue. And we're going to verify that, yes, where these f of x equal g of x was definitely when x is equal to 2. So what I like to do, we'll graph this. First one, we're going to go to 5. 1, 2, 3, 4, 5. Plot that point. Have a slope of 3. Up 3 to the right 1. Plot a point again. All kinds of room. You can go up 3, right 1 again. Plot a bunch of points. But again, my PowerPoint has the ability to graph straight lines. G of x, negative 2x plus 15. So if this is 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 more up will give me 15 right there. Down 2 to the right 1. Down 2 to the right 1. There's my intersection point. And that's at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, the 11, I could have also gotten that algebraically. Once you find the value of 2, when we did it algebraically earlier, take the 2, plug it into either function. 3 times 2 is 6, plus 5 is 11. Negative 2 times 2 is negative 4. Negative 4 plus 15 is 11. So what I'm saying here is that the graph is always worth 1,000 words. They can give you so much more. Now, I know what you might be thinking. Well, it's kind of a pain to have to make a big graph. No, just rough estimate it. You don't have to make a perfect graph. What you really need is just your y-intercepts and your point of intersection, and you are in business. Okay. Trying to get my iPad here up and running here so we can look at an example for you here and what I'm talking about. How to make this quick and easy. Hopefully it's going to pop up. There it is. Good. No. That's what I wanted. Hit the wrong button. Come on. There we go. So here's kind of what I'm talking about, your graph. You don't have to make a precise graph. All right, so in red, we said we had, well, let me make my XY coordinate plane here. Rough sketch. Red graph. Had a y-intercept at 5. Had a positive slope of 3. That's all I need. My other graph, we had that in blue, had a y-intercept of 15. It's right there. Had a negative slope. There it is. Had an intersection point. Let me get to that intersection point. Right there. Now, that's at 2, 11, because I could do that all algebraically, like I said earlier. But when we get to the inequality parts, when you get to the inequalities, if you want to make sure it's right, for example, when f of x is greater than or equal to 0, I want to find the red curve. Now remember, this is the f function, this is the g function. At that x-intercept, which we found algebraically to be a negative 5/3, everything to the right is going to give me positive y's. So my graph can answer those inequalities really fast. When we had the f of x was greater than or equal to g of x, in other words, when is the red curve? When is the red curve above the blue curve? That's right here, starting at 2 and everything going to the right. So x is greater than or equal to 2. Now, if, like I said, the author switched it around and said g of x is greater than or equal to f of x. Okay, now the g function, that's in blue, when is the blue graph higher than the red graph? Okay, well now we can clearly see we want to start at that 2, but now we want to go to the left. So that would be x is less than or equal to 2. So sometimes doing your inequalities using a graph, you can visually see and compare your inequalities. Who's bigger, who's smaller. You use the algebra to find the key points.